Hey folks, today we will talk about air interface protocols in LTE. It is a very big topic, so in this video we will just have an overview. We can divide air interface protocols in two parts, user plane and control plane. User plane deals with actual data flow, whereas control plane is used to configure user plane layers before actual data flow. Let's talk about user plane first. When data comes from EPC, it is stored in PDCP buffer at eNode B. So let's first talk about PDCP layer. PDCP means Packet Data Convergence Protocol. First task performed by PDCP is header compression and header decompression of IP data packets. Data packets reaching to eNode B from EPC are IP packets. Each IP packet has a header of 40 bytes. These 40 bytes of IP header do not have any meaningful information, so sending these 40 bytes of header along with actual data on air interface is sheer wastage of resources. Moreover, in case of VoIP call, in which size of actual data is very small compared to IP header, this header is considerable overhead. So we need some mechanism to compress this header. At transmitting end, PDCP layer compresses this header using ROHC or robust header compression protocols. At receiving end, PDCP layer decompresses this header. Second task is maintenance of PDCP sequence numbers. At transmitting end, PDCP layer assigns sequence number to each packet before sending it to the next layer, that is RLC. This sequence number is used by PDCP layer at receiving end to align packets in a sequential order before sending them to upper layers. At the time of handover, PDCP layer of source eNode B sends sequence number of the last packet successfully received by UE to the target eNode B. So the target eNode B can start transmitting data to UE from that packet onward. This way, two eNode Bs can synchronize data flow at the time of handover using PDCP sequence number. Third task is security of the data. If your data is not secure on air interface, somebody may intercept this data. For example, online payment on your mobile will no more be secure if there is no security mechanism. So we need to secure this data by integrity and ciphering before transmitting it on air interface. Now let's come to RLC layer. First task performed by RLC layer is concatenation, segmentation, and reassembly of RLC SDUs. Although header of IP packet is of fixed size, that is 40 bytes, but data part is variable. For example, in case of VoIP call, data part is small, but in case of video streaming, data part of IP packet is quite big. Bandwidth available on air interface keeps on changing very frequently because of changing radio conditions and changing number of UEs under an eNode B. So RLC at the transmitting end has to concatenate or segment these data packets dynamically according to the current bandwidth on air interface, and RLC at the receiving end does reassembly of this data. Retransmission of RLC PDUs. This is the next task. If data gets corrupted on air interface, then RLC layer of the transmitting entity has to send data packets again. But this kind of transmission is done only when RLC is in acknowledgement mode. Example of AM RLC is data download using FTP. Next task is reordering of RLC data PDUs. Let me tell you the reason for this. Because of multiple retransmissions, order in which packets are received at the receiver could be random. So RLC has to reorder all the packets before sending them to the upper layers. Now let's come to MAC layer. MAC layer is responsible for prioritization among various data streams for a given UE. We know data packets of different streams have different priority based on their types. For example, packets of VoIP call are of highest priority, When available bandwidth on air interface is not enough to carry all the data streams, there should be some entity that selectively sends data, which belongs to highest priority stream on air interface. This role is performed by MAC. Error correction through HARC. This is the next task. HARC means Hybrid Automatic Repeat Request. It is an error correction technique that has been taken from UMTS. Finally, let's come to physical layer. Physical layer encodes raw data before modulation. We cannot use raw data for modulating a carrier signal. Data has to go through an encoding process before modulation. This processing is called physical layer processing. This processing is needed so that receiver can detect any error in the data caused during the transmission on air interface. If forward error correction techniques are used, then receiver can correct the data at its end if there is some corruption in the data. If data can be corrected at receiver end, then there is no need to retransmit the data. Physical layer measures the air interface to know channel quality. Let me tell you the reason behind this. Because of mobility, multiple reflections from the surroundings, and noise on air interface, available bandwidth on air interface keeps on changing very frequently. So we need some mechanism to measure air interface quality to know the current channel bandwidth. So this is the reason behind these measurements. Now let's move on to control plane. Most important layer in control plane is RRC. You can estimate its importance from the fact that RRC layer initializes other layers such as PDCP, RLC, MAC, and physical layer. Then only actual data transmission takes place. I will quickly go through the list of tasks performed by RRC layer. Very first task is broadcast of system information. In a cell, MIB or SIBs are broadcast by RRC layer. MIB and SIB contain all the cell and network related information. Whenever an UE is switched on or an UE moves to a new cell in idle mode, it decodes its broadcast information to get all the cell parameters such as cell bandwidth, etc. Next task is RRC connection control. RRC layer of UE triggers RRC connection with RRC layer of E node B. Note, it is obligatory for an UE to have RRC connection before sending data packet to the network. Without RRC connection, UE cannot send any data to network. When an UE does not have RRC connection, it is said to be in idle mode. Next task is state transition. RRC layer of E node B triggers the state transition in UE from idle mode to connected mode and vice versa. When there is inactivity in data flow for a particular UE for a long time, RRC layer of E node B triggers RRC connection release for such UE and sends such UE to idle state. When UE has some data to transmit, it can trigger RRC connection setup process. State transition is performed to save UE battery and air interface resources. Next task is paging. Whenever there is some empty voice call or PS data to be sent to an UE, RRC layer of E node B sends paging message for that UE in the UE's tracking area. Initial security activation. At the time of RRC connection setup, security keys are exchanged by RRC layers of E node B and UE. Also, security algorithm to be used is also decided at the time of RRC connection. Note, integrity protection is not done for DRBs. Measurement, configuration, and reporting. In connected mode, an UE has to do many types of measurements such as interfrequency, and inter-rate measurements. All these measurements are configured in the UE by RRC layer of E node B. RRC layer of UE reports all the measurements to RRC layer of E node B. Based on these measurements, RRC layer of E node B takes all the handover related decisions. Finally, let's come to NAS layer. NAS layer is also part of control plane. NAS layer is composed of EMM and ESM layers. EMM means EPS mobility management, and ESM means EPS session management. EMM layer takes care of mobility related scenarios such as tracking area update, paging, security mode control, and authentication, and other tasks like that. ESM layer takes care of bearer related scenarios such as default EPS bearer context activation, EPS bearer context modification, PDN connectivity procedures, PDN disconnect procedure, etc. So this was all about the protocol stack in LTE for air interface. In next video, we will talk about few other scenarios such as RC connection and handover. So just keep tuning in and hit the like button if you enjoyed the video, and keep watching and keep waiting. And you can subscribe for this channel. Bye bye. See you next time.